I've built it, I've been using it for about a month, and I've been teasing it on social media. I'm finally ready to show you my 12-core, 24-thread Xeon video rendering machine. Let's go ahead and take a look. So you're probably wondering, why? Why now? Why am I talking about this PC now after I've built it and I've been using it for a month? That's a valid question, person who didn't ask any questions. The reason I'm talking about it now is that I've finally settled on a video card. You'll see in some of the B-roll from my build explanation that I was using an old iSilence 7750. Completely fanless, has a giant blue heatsink on it. It's a really nice card. Really quiet, very cool, low power. It just wasn't really fast enough for what I do. I don't play a lot of super complicated games, but you know, I have a 1440p monitor, and having to run all of my games at 720p to get playable frame rates is not making me a happy girl. So while I was helping my housemate build her new Ryzen PC and helping transfer the guts of her old PC into an old case, she mentioned that she still had her old video card sitting around. And she wondered, I asked if I could trade her for it. It's my 7750. So I was pretty sure whatever she had was going to be faster than that 7750. She said yes, and what she had was faster than it. Blast from the past. GTX 465. Yep, it's a Fermi card. It's not even top of the line, and it takes two 6-pin power connectors. So I've been using that for the last month or so, trying to make it work, and trying to make it functional for my needs. Unfortunately, it still doesn't have quite enough oomph for my 1440p monitor, and I'm kind of sick of running everything at 1600 by 900. Also, it gets amazingly warm when it runs. If you've never had the joy of experiencing a Fermi graphics card, they're one of NVIDIA's hottest running line of cards ever produced. And this would frequently, while playing a game, this would frequently get to 93 degrees Celsius. Yeah. With that little blower fan to cool it off, it was quite loud. So, as functional as it wasn't really doing it for me as far as a livable PC that I can keep in my bedroom and not, you know, turn it into a space heater that's also obnoxiously loud. So today, I just received my replacement card. Since money is tight, I decided to go with an inexpensive card, and given the GPU market these days, there aren't a whole lot of inexpensive cards that are worth buying. I briefly considered the GTX 1060 because I think it's a really good value for money leader as far as NVIDIA's graphics cards. AMD's cards still tend to run a bit too hot and tend to be a little too power hungry for me, for my liking. Their new, since they introduced the Maxwell architecture and then the Pascal architecture, their cards have been runaway power usage mavens. I've been really happy with how little power they use and how little heat they produce. So I settled on kind of an interesting choice. I settled on a GTX 1050. In particular, this version, which is the MSI dual fan, I think the MSI Armor version, or the OC edition. I don't know, they have about 18 SKUs for the GTX 1050 and 1050 Ti. It should be about twice as fast as the old 465, and it has an enormous cooler on it. This dual fan cooler is not just for show. However, you'll notice that it has no heat pipes, not a one, doesn't need any, because it also has no power connector. It is powered entirely by the PCIe slot. So it's definitely lower power than the 465. So with this video, I'm going to walk through the build of my PC And I'm also going to have some B-roll of me installing the GTX 1050, so stay tuned. Well, let's jump right in. The CPU is a Xeon E5 2696 V2. It's a 12-core, 24-thread Xeon, running on the socket 2011 V2 platform X79, C602, etc. In this case, I have a generic C602 board that I bought off of eBay, and I'm cooling the whole thing with a Cooler MasterLiquid Lite 120. You can see here I've got some B-roll of it running on my test bench outside of the case, just to make sure all the components work. I've got my 16 gigs of RAM, my little tiny micro keyboard that I use for testing, stuff like that. My biggest issue, and here you can see a great shot of the heatsink on that old 7750. My biggest issue with this case, if you've never used a Silverstone Fortress FT03, it's a great case. The only real issue with it is it's so frickin' small. It's a micro ATX case, but it's just micro ATX. Like you can see here when I take the doors off of it, there's not a whole lot of room to work in there. All of your cable management's on the back side, and that motherboard compartment is just big enough to fit a micro ATX board. There's maybe a centimeter and a half on either side of it. My biggest issue though actually was fitting this cooler. This huge 120mm water cooler. I didn't think I'd have as much trouble fitting it as I did. I ended up having to put the fan on in a pull configuration in order to get the thing to mount. I didn't have enough room for mounting it the correct way. In the end, I did end up getting it to fit, and I think actually the end result was kind of pretty. Of course, it's a windowless case, so nobody gets to see it except me, and I guess you right now since you're watching the video. I think it came out really well. Airflow is fantastic, it's a really clean interior. So the last step, of course, is installing the GPU, the GTX 1050, which honestly, with no power cables, a pretty simple affair. Take the cover off the PCI Express slot, stick it into the motherboard, and then of course, once it's in there, which easier said than done on this case, there it is. Ta-da! Finally, screw in the screw and secure it to the case. I've got some numbers from Guild Wars 2 where I did a large amount of testing. Yes, I play Guild Wars 2, I play MMOs, shush. There actually appears to be a CPU bottleneck in that game, even with a GTX 1050, even at 1440p. Because of the low single-threaded performance of this CPU. Remember, if we're under 4 threads, if we're under 5 threads, we're only running at 2.5 to 2.6 gigahertz. So it's pretty easy to saturate that on an Ivy Bridge architecture. Most of the Ivy Bridge CPUs of the time were running at, 3.3 to 3.7 or so gigahertz. So you can see why the 2696 isn't the best CPU for gaming on. Now, some of you might be saying, hey, hang on, I'm looking at it on Wikipedia here, and it says that this thing should go up to 3.5 gigahertz, and you're absolutely right. If it wasn't an engineering sample, its turbo boost would be correct. The thing is, it's a B-stepping engineering sample, and those are still a ways off from production, so they're still missing some components. Either cores are deactivated or features are missing, and in this case, the turbo boost is not correct. 1 to 4 cores, it runs at 2.5 to 2.6 gigahertz, and 5 cores or more activated, 5 to 24 threads, it runs at 2.8 gigahertz. It's a completely bizarre turbo boost number, but that means it's still pretty good at rendering video because all 24 threads are utilized. But it means that gaming, it is completely garbage. And I'm going to go over that in detail in just a second here, because I think it's actually kind of interesting. A lot of folks don't understand the whole CPU versus GPU bottleneck thing, and I think I've got a pretty good explanation here, just using Guild Wars 2. But first, let's take a look at just the bare GPU benchmarks. moving from a GTX 465 to a GTX 1050. It was about twice as fast as I thought, but let's take a look at those benchmarks in detail. So we'll get right into the GPU benchmarks. We're going to start out with Geekbench 4 GPU compute. We see that we almost doubled we over doubled the score from 34,000 to 78,000. Then we have Cinebench R15, the real-time demo in OpenGL. It nets us a 10 FPS improvement over the 465. Unigen Heaven 4 with the Extreme preset gives us a score of 1066 at 42 FPS on the GTX 1050. And Superposition shows us a very cinematic 24 FPS versus the GTX 465's 8. We have a number of 3D Mark benchmarks here. I did do 3D Mark 06 for historical reasons. You can see there isn't a whole lot of improvement. There's not a lot of driver optimization for DirectX 8 and 9. But 3D Mark Vantage showed an improvement of almost double from 15,000 to 29,000. Finally, we had the modern 3D Marks, with Skydiver reporting a score of 21,219, Firestrike of a score of 6,346, and TimeSpy giving us a 2128. TimeSpy was hilarious. It does actually run on the 465 since it is technically a DirectX 12 GPU. It had a performance of 1 frame per second. The 1050 scored between 8 and 12 frames per second. Finally, I did do some testing in Guild Wars 2 at 1440p best appearance preset, standing at the Trader's Waypoint in Lion's Arch. The 465 returned 19 frames per second. The GTX 1050 returns a score of 34 frames per second. It was a particularly busy day, and I found that there was a CPU bottleneck actually. Reducing the render scale and turning down video options didn't really net an enormous performance gain. I was able to get up to like 38 frames per second if I turned down some of the options, but mostly this was CPU bound at this point, which is incredible to say on a GTX 1050 and a 12-core CPU that you are CPU bound, but that is the case, at least in this game. So I know a lot of you are curious about the CPU benchmarks and the performance of the 12-core Xeon. It's really, really good at multi-threaded performance. You can see with the Geekbench score there of 21,980, it's fantastically good at multi-threaded things. Cinebench R15 runs with all 24 threads, yielding a score of 1463 CB. The Corona benchmark finishes in 2 minutes 17 seconds. Similarly, the Firestrike physics score is 15,600 and the TimeSpy CPU score is 7421. Where things break down, though, are in single-threaded tasks, like SunSpider in Microsoft Edge, returning 143 milliseconds, which is not great, honestly, for a desktop system, for a browser. That's not wonderful. Also, the Dolphin benchmark takes a glacial 14.5 minutes to finish. This CPU can still emulate Dolphin at native resolution, it's fine, but it's not a fantastic single-core CPU. Finally, I decided to run a pure math benchmark, W prime 2, at 1024 million primes. Was able to solve them in 105 seconds, so it's a very, very fast multi-threaded CPU. It's really not meant for single-threaded tasks, and we're actually going to jump in really quickly to take a look at the CPU bottleneck that's present in Guild Wars, for example. So one of the things that surprised me about the Guild Wars result, the 34 frames per second in Lion's Arch, is that most of the time when I'm running around the overworld doing quests or running through my story mode and stuff like that, I don't see an awful frame rate drop. Things are mostly 60 frames per second pretty much wherever I go. So what I've determined is that it's player density that slows the game down. That's the origin of the CPU bottleneck. We can see here, this is just me standing around in a field somewhere in Tyria, and there's not a whole lot on screen. There's some shaders for weather and my pet robot cat, but we're getting pretty decent frame rates here. Let me zoom in really quickly on our info here, so you can see we've got good utilization numbers. Guild Wars uses the same 3 threads it always uses, 3-ish, it's like 2.5 threads. But you can see, with these numbers, with these settings, we're getting good GPU utilization, 96, 97, 98%, and we're getting good frame rate numbers, right around 60 frames per second, which is perfect. It's wonderful, really smooth, fluid playback. The problem comes in when you're in a highly populated area like Lion's Arch here, and once you're here, things kind of break down a little. You can see, if we zoom in on our info, Guild Wars still uses those 3 threads. Our settings haven't changed, but you can see our GPU utilization is between 80 and 85%, which is pretty bad, especially given an area that's more technically difficult to render. And the issue, I think, in Guild Wars at least, comes down to poor CPU optimization in player rendering. In most games, this isn't a problem. Another game I frequently play is Saints Row 4, just for the lulz. Oh my god, seriously, the mission where you save Asa, and it's like a lampoon of every Metal Gear Solid game ever. It's fantastic. It's so funny. Anyway, yeah, in most games, there's no issue with CPU utilization. Frame rates are good, they're consistent. There's some stuttering in this video just from recording while playing. Unfortunately, there are still issues with getting frames off the stupid frame buffer, but that's computers for ya. The gameplay itself was perfectly fluid when I was playing this. So most games have no issues, and that's how most games run on this system. You have 24 threads to spread things out on. There's really no stutter in a game. It's pretty fluid. There's no real lag. Really the only issues are games that are poorly optimized for multiple threads. And that's most games. The most I've seen in a game is Planetary Annihilation will sometimes when it's loading, use up to 6 or 7 threads, usually about 6. But yeah, that's it. This machine, honestly, I'm super, super happy with it. Doing video rendering and music mixdown in Cubase, video rendering in DaVinci Resolve, and even the slick little motion graphics I had at the start of this video, I did in DaVinci Fusion, and it rendered out great. The CPU is really powerful. It's not the best gaming CPU in the world, but geez, for getting stuff done, it's fantastic. I really love it. Overall, I'm super happy with this build. I realized that a Ryzen 7 would actually be faster. Yes, in single and multi-threaded performance, a Ryzen 7 1700 with a mild overclock would actually be faster than this CPU, but I'm okay with what I have. It was pretty inexpensive given that I didn't have to buy the RAM. I mean, the other components I could have, no price difference, reusing my storage and stuff. But I'm pretty happy with this machine overall. And you know what, I'm going to leave the comments open on this video for once, and let me know what you think about the builds. I know if I've omitted any information, please ask for it, let me know, and I'll throw it in the comments. Yes, I know, trans woman opening up her comments on YouTube is inviting some fun trolls, but I'm going to try and police the comments section pretty well on this one, so please leave a comment if you like or don't like the build. If you have any questions about how it runs certain things, I can certainly answer it, or if it's a free program, I can benchmark it and let you know how it does. So in the end, that's all I've got. It's an information-packed video, and I'm sorry for making it super long, but this is the machine. I am very pleased with it. It's actually pretty quiet. Even if you spool up all 24 threads, it stays fairly quiet under load. I'm really happy with it. Its temperatures are good. CPU tends to stay in the 60s under load. GPU, I don't think I've seen hit more than 70 Celsius, and that's with a mild overclock even. So yeah, I'm super happy with this build. Let me know what you think in the comments. And thanks for watching, of course. See ya.